Good.
I already told you this yesterday.
I thought you meant one section.
No, I did all of them. I did everything.
I would like to repeat. Do not do C until you're done with B. And, you could show them to me at lunch if you want.
I know, but
Now,
I keep forgetting.
All right, we don't have extra help on Monday because there's no school. Tuesday night, Patrick Medford Library. A lot of kids bring them to the library. Just make sure you've watched the videos already. Otherwise, watch the video while you're at the library. And then Wednesday, Thursday morning here. What's that?
You're talking about Oreos.
In the video, I talked about Oreos?
Yeah, you were.
Really?
You said you go and get your Oreos and start eating them, and then you were like, oh wait, you don't have any Oreos.
And then you said I really shouldn't talk on a mouthful.
Yeah, I remember doing that part, yeah. Well, you know what it is? You got to have fun with it. You can't let the schoolwork get boring. I told you that yesterday. When schoolwork gets boring,
You were like, ooh.
hurt my feelings.
You made a teacher cry today.
Yeah.
That was on my bucket list.
They've done it many times.
Your bucket list?
You're a bucket dipper.
You don't have a bucket list. You're too young.
I have a bucket
You're the
list.
second
I live like it's my last day.
YOLO.
Wow.
You are the second young lady to talk to me about a bucket list today. You know who the other one was? Mrs. Bing. She's 35. When the doctor says you have cancer, you start thinking bucket list. 35? No. 8th grade? No. Do you know what Mrs. Bing did to accomplish her bucket list item?
She went skydiving.
No.
She raised money for a cause.
No. She went to a Ricky Martin concert.
So did my mom.
Apparently, oh my God. So you need to talk to Mrs. Bing about this. Apparently, when Mrs. Bing was in college, she had a Ricky Martin poster in her room, a very big Ricky Martin poster. And it was apparently a big day today. So she has like a little Ricky Martin, like one of these things, with a Ricky Martin face on the top that she's walking around with in school. What?
Who's that man on the top now?
That's Morgan Freeman. You should know Morgan Freeman. He's a great actor. So, okay. Duke!
I'm alive.
The minute it says Duke, I start thinking of a dog.
She's a zombie.
Duke starts at the base of a ramp and walks up it at a constant rate. His elevation increases by 3 feet every second. Just as Duke starts walking up the ramp, Shirley starts at the top of the same 25-foot high ramp and begins walking down the ramp at a constant rate. The elevation decreases 2 feet every second. Sketch the two graphs. Now, this one they're much more specific about because they're giving you an exact speed. So you have to be aware of that when you start writing this down. So I think it's important to put a scale on this, okay? Because I can't fit all 25 on this. And then I'm going to go by twos here. 12, 14, 16, 18, 20. 30. Okay. So, let's do Duke first. Duke starts at the base of the ramp and walks up it at a constant rate. His elevation increases by 3 feet every second. So here's Duke, up 3/1. That means I have to end up in the middle there. It's kind of hard to do this when you're up to the side. Up 3/1, up 3/1. So here, stay like this.
Okay.
This is Duke.
Why just go with threes?
Well, I couldn't fit up to 25 if I went by. Oh, if you went by threes, you could, but the problem is the other one goes by twos.
Oh.
So if you went by threes, then you would have a hard time with the other one. Yeah. So, yes.
I went up by 1.5.
You could do 1.5s. You can do whatever you want. Nobody's wrong. Let's be clear on that. I don't care what scale you use. I just care that your scale is consistent. Next, Shirley starts at the top, 25 feet high. So here's 25 feet. 2, 4, 6, so 25 is right there. And this one goes down at 2 feet per second, which amounts to going to the middle every time. There we go. See, look at that. We nailed that. And this would be Shirley. Forgive that I went over here, and I really should not put an arrow on the end of Duke because you can't walk forever. Okay. So then it says here, sketch of two graphs. I did that. Elevation versus time to represent Duke's and Shirley motion. Good. What are the coordinates of the point of intersection? That's here.
5:15.
And yep, 5:15.
I'm so behind.
It is. Okay? So 5 seconds later, they meet 15 feet from where Duke started walking. It's 10 feet from where Shirley started walking. Okay. What does it say? Is there a next question that follows up after this? I don't want to leave the page. Oh, on the top of the next page, is there a question?
Oh, yeah.
Yeah, what does it say?
Write down the equation of the line that represents Duke's motion as he moves up the ramp, and the equation of the
And then
line.
Shirley also?
Yeah.
Okay. Look, what kind of functions are these?
Linear.
Linear. What is the general equation of a linear function always going to be? Y equals mx plus b. Nicely done. So in Duke's case, what is the slope? The rate of change. Alex? Good. So it's y equals 3x, and what's the y-intercept? 0. Starts right down here. So his equation is y equals 3x. Next, let's start with Shirley here. What's Shirley's equation going to be? Again, it's linear, so it's y equals. What's the slope of Shirley? Come on now. Somebody other than Alex. I know Alex knows. Go ahead. What kind of 2? Negative, right? Because this slope is going down. So when it's going down, it's going to be negative. So y equals negative 2x. But she clearly has a starting point, not 0. What is Shirley's starting point?
25.
25. Good. So y equals negative 2x plus 25. So Duke's equation in blue, y equals 3x. Shirley's equation in red, y equals negative 2x plus 25. Now, I would like to talk just for a moment about one of the things I really appreciate about mathematics, and that is the consistency of it. When I was in school, I was accelerated in everything except math until I was in 11th grade. Then in 11th grade, I took a challenge from a teacher. I did unbelievably well in trigonometry, which is supposed to be the hardest of the maths, except calculus. And then I actually took pre-calc and calc at the same time as a senior. I took 2 math classes. Now, in so doing, I learned to appreciate the consistency of math. I used to think it was just a bunch of rules, and now I learned to see the brilliance of it. And what I mean by that is something like this. If you took American history, which I loved, I still, at home, I watch history shows on TV and biology shows and stuff. If you take American history and you discuss the concept of manifest destiny, are you familiar with that? Excellent. If a Native American Indian wrote the textbook and discussed the topic of manifest destiny, God bless, do you think it would read the same as if a descendant of the Pilgrims wrote the textbook on manifest destiny? No, I don't think so. Right, because it's opposite points of view, and they don't lead to the same logical conclusion. Well, in math, no matter how I look at it, it's going to work. I could graph it, and I find that at the time of 5 seconds, at a distance of 15 feet from where Duke started, which is 10 feet from where Shirley started, they're going to intersect. Now, that's the graphic way to do this. I could also look at it algebraically and say, well, when do these two things intersect? If they intersect, then that means they must equal each other. Ooh, 25. So I'm going to solve it this way. Add 2x to both sides. And later in the year, we do a lot of this algebraic work. Oh, this is 5x, I'm sorry. 5x is 25, divide by 5. And what does x work out to be? 5. And then the y is 3 times x, so the y is 15. So whether I did it algebraically or whether I did it graphically, I'm still going to end up with the fact that at time 5 seconds, they cross 15 feet from where Duke started, 10 feet from where Shirley started. Whereas in social studies, you could get in these big, long debates and go on forever and ever, and you could feel exactly the opposite that another person feels. And I don't think there ever is an arbiter that says, this is necessarily the correct answer. Need I point more than to our elections? I will ardently argue that Obama is ruining our country. Another person could stand right next to me and say that I am out of my mind and he is saving our country. Now, of course, they're dead wrong, but that's the nature of something like that and what you see. So the beauty of math is its consistency and the fact that at the end, there really is, you can't argue against the 5-15 answer, and I don't care how you try to argue against it, you're not gonna win. Okay? Any questions? All right, so the next part of today is to just start your homework. So get going, and you might actually end up this weekend without homework.
Okay, Maya, start doing work.
If any of you, because I am finishing a little early,